All right, everyone, we're going to do more practice with linear regression. Remember, if you don't have a graphing calculator, download the Calculate 84 app. All right? All right, here we go. All right, first off, if you're given data and it's not clear which is the X and which is the Y, the first row or the first column is generally going to be the X, and the second row or column is going to be the Y. So when I go to enter this data in, I'm going to enter in the elevation as the X and the temperature as the Y value. Okay? So this problem's talking about the mean annual temperature. I believe it's in Nevada. Right? So they collected the average temperature, the mean temperature over all these different elevations. All right? Here we go. Ready? You go stat, you go edit. You do the up arrow to the top of the list and you hit clear, the down arrow, and it clears it all out. All right? So now I'm going to enter all these numbers, the elevations in for my X values. All right? So enter that in as I go. Maybe pause the video, enter in the data. All right, make sure you enter this data in accurately, because if you mess up one number, that's going to change your whole equation. Now I'm going to enter in the temperature for my list 2. That's my Y values. All right, so pause the video, enter in your Y values. All right, you want to make sure that you entered everything in carefully. So I'm going to look at my table. Right, and the last one should be 31, 60, 49, 49, and I put in 59. See that? So I fixed it. It's a good thing I'm checking. All right, 18, 64, 58. Checks out. 43, 75, 40. 63, 28, 32. 56, 25, 48. 23, 78, 51. 62, 30, 36. 41, 25. And 45, 1,262. So all of my data is in. All right. Once you put in the data, you just hit the stat button again. Ready? Stat. Hit the right arrow over to calculate. Go down to linear regression. Okay. This is what should pop up on your screen if you have a graphing calculator. It's going to look possibly slightly different if you got this app. You got to hit enter 4 or 5 times. And all this information is going to pop up. See, it's giving you the general form, AX plus B instead of MX plus B. So this A value is your slope, and that B value is your y-intercept. So it's saying round the slope to the nearest thousandth. So that's 3 place values. So I'm going to write A over here, 0.0045. All right. Keep in mind, this is tenths, hundredths, thousandths. So that 5 is going to make the 4 in the thousandths plates go up to a 5. So my equation, y equals negative 0.005x. And then my y-intercept, my b, was 65.045, and it says to round that to the nearest integer. So that's the 5. The value to the next value to the right is 0, so we're going to stay. So plus 65. All right? All right. Using the correct units, okay, give an interpretation of the slope of this line. So your slope, okay, is negative 0.005. All right, keep in mind, when you do slope, it's rise over run. Degrees Fahrenheit per foot in elevation. So what does this mean? The temperature drops 0.005 degrees for each foot in elevation. So every foot the elevation increases, the temperature drops 0.005 degrees. All right? There's a question later on that asks you to interpret. I think it's going to be a little easier for you to figure that out. But if not, check my answer key. All right, C. Using your equation, determine the predicted mean temperature at an elevation of 3,000 feet. So they're giving us the elevation. So they're giving us the x value. So this 3,000 is our x. So we're going to take our equation, negative 0.005 x. We're going to put 3,000 in for x plus 65. All right? And we're going to round to the nearest degree. So I'm going to plug that in exactly the way I see it. Negative 0.005 times 3,000 plus 65. Right? Just like that. And that's going to come out to 50. So 50 degrees. So at an elevation of 3,000 feet, we would predict that our temperature would be 50 degrees. All right, D, determine the correlation coefficient R. So I'm going to go back and I'm going to, I'm going to go back and pull my regression again. All right. R is negative 0.9048. Let's go to the nearest tenth. So negative 0.9. All right. Now, the closer to negative 1, the stronger the relationship. The closer to 0, the weaker. All right? The closer to positive 1, the stronger the positive correlation. The closer to negative 1, the stronger the negative correlation. So negative 0.9 is very, very close to negative 1. So this indicates a strong negative correlation. All right? Yesterday, our number was like 0.85, and since that was close to positive 1, that was a strong positive correlation. But this time, our R is negative, so it's going to be a negative correlation, and since it's really close to negative 1, it's a strong negative. Now, if it was, let's say, negative 0.3, that would be a weak correlation because it's close to 0. So the closer to negative 1 or 1, the stronger the correlation. The closer to 0, the weaker. All right, why don't you try the rest of the questions, and I'm going to post the solutions. All right? Email me with any questions. Talk to you soon.